All right, we're ready to talk about three dimensions. We've actually already done a lot of this when we did vectors. We did vectors in a plane, or in space, rather. Vectors in space was three dimensions. Most of the stuff is just like we do in two dimensions. It's just you're adding a third dimension. I think the hardest thing is actually plotting the points, which is normally the easiest, but it's hard to visualize this in three dimensions on a two-dimensional surface. A couple of things here. First, the points are listed, of course, with three. You have x, y, and z. That's the three dimensions. It's called an ordered triple. Now, they kind of adjust where the axes go. X is kind of coming out of the plane, where it's positive in the front, negative in the back. So x goes this way. Y is horizontal, so it's positive to the right, negative to the left. Z now is vertical. So Z goes vertical, so it's positive going up and negative going down. So here's like the three planes. You have the XZ plane, which goes right through goes right through the Z axis. Anyway, it's the X axis and Z axis. It's perpendicular to Y. You have the YZ plane, which goes through Y and Z, is perpendicular to X. And the XY plane, which goes through X and Y, is perpendicular to Z. A lot of times you can think of the right-hand rule. If you think of this, X is positive here, so if you curl your hand, there's X is positive, Y is positive as you keep going, and then if you point your thumb up, Z is positive going up. You'll see this represented different ways, but this is just one of the ways we're going to look at it. So here is that same axis. You can see here's the x-axis. It's positive out here, negative back here. Here's the y-axis here. It's positive going to the right, negative back to the left. And the z-axis is vertical, positive going up, negative going down. Now there's put some points on here. If you follow through the dotted lines, you can kind of see how they plotted them. Like here, 2, negative 3, and 3. That means x is negative 2, so they came out two spaces here on the x-axis. Y was negative 3, so they went back 3, and notice they kind of went parallel to the y-axis. That's why it looks like it's kind of at an angle here. And then Z was 3, so from there they went up 3. If you didn't put these little dotted lines, that point could be about anything you wanted to dream up. But here we just kind of followed the dotted lines. Or this point over here is negative 2, 6, 2. So negative 2s, that means they went backwards here on the x-axis, so there's negative 2. Y is a positive 6, so they came out to the right here, positive 6. Again, notice they made this line parallel to the y-axis. And then from there, they went up 2 for Z. Or this one here, 1, 4, 0. X is 1, so they went out 1 on the x-axis. Y was 4, so they went to the right 4 for the y-axis. And then Z was 0, so they left the point right there. Or this one here, 2, 2, negative 3. So X is 2, so they went out 2 on the x-axis. Y was 2, so they went right 2 for the y-axis. And then negative 3, so they went down 3 for the z-axis. If you had trouble following those, it's understandable. If they didn't have the dotted lines again, it'd be really hard to decide exactly what those points are. Again, I think that's the hardest part. Now, the easiest part is what you do with the rest of things, like the distance formula. We did the distance formula before with 2, and it looked like this. The square root of x2 minus x1 squared plus y2 minus y1 squared. All we do with three dimensions is we add z2 minus z1 squared. So if I give you 2 points and say find the distance between them, you subtract the x's, so 2 minus 1 squared. You subtract the y's, 4 minus 0 squared. And you subtract the z's, negative 3 minus 2 squared. And then we're going to square root that whole thing. You can see we just took the point from this, a coordinate from the second point, and subtracted a coordinate from the first point. So 2 minus 1 is 1, squared is 1. 4 minus 0 is 4, squared is 16. Negative 3 minus 2 is a negative 5, squared is 25. We add those together, we get 42, so that's the square root of 42. That's our distance. Nothing to it. Midpoint formula. You did midpoint back before. Again, midpoint with 2 looks like that. We average the x's, so x1 plus x2 squared. And then we average the y's, y1 plus y2 squared. All we do for 3 dimensions is we average the z's, z1 plus z2 squared. So if I wanted to find the midpoint of this point up here, we just do that. We average the x's. So it'd be 1 plus 2 divided by 2. Then we average the y's, 0 plus 4 divided by 2. And then we average the z's, 2 plus a negative 3 divided by 2. Now simplify that, 1 plus 2, that'll be 3 halves. 0 plus 4 is 4 divided by 2 is 2. 2 plus a negative 3 is a negative 1 divided by 2. And that's our midpoint. The next one is the equation of a sphere. It's just like the equation of a circle, except we add the third coordinate. So x minus h squared plus y minus k squared equals r squared. That was a circle. All we do for a sphere is we add z minus j squared. And so the center of the sphere is hkj. Radius is still r. So here, if I want to find the equation of a sphere, here's the center, 2, negative 4, 3, and the radius is 5. We're just going to plug it into there. So x minus 2 squared. Negative 4, so that'd be y minus a negative 4 squared. The z-coordinate is 3, so that'd be z minus 3 squared equals 5 squared, or 25. And that's our equation. Now this one is one, we've done these before, where we have to complete the square. Remember, to complete the square, the first thing we do is group the x's and y's. So I have x squared minus 2x, and I'm going to leave a little gap. Then for the y's, I have y squared plus 4y, leave a little space. And then for z's, I have z squared minus 6z, leave a little space, and then move the constant to the other side. If you remember, we did this before, completing the square, nothing different. Now to complete the square, first with the x's, we bring down the x. Remember, we take half the middle coefficient. So half of a negative 2 is a negative 1. We're going to square that because we're completing the square. Negative 1 squared is a positive 1. If I add 1 to the left, I also have to add 1 to the right. Do the same thing with the y's. Bring down the y. Half of 4 is 2. 2 squared is 4. So we added 4 to complete the square. If I add 4 to the left, I also have to add 4 to the right. Now the same thing with the z's. Bring down the z. Half of a negative 6 is a negative 3. Negative 3 squared is 9, so we need to add 9 to complete the square. So we add 9 to the other side to keep the two sides balanced. So we just completed the square 3 times. Here, if we combine like terms, that'll be, 14 minus 8 is 6. There's our standard equation of that sphere. If they asked you for the center, it says find the center, well, the center would be 1, negative 2, 3. The radius, this is radius squared, so the radius is the square root of 6. So all that is really stuff we've done before, except now with 3 dimensions. Now the last thing is called a trace. Now this is something different. A trace is like if you cut a cross-section through a sphere. So an XY trace would be like cutting through the sphere horizontally, because X and Y run horizontal. Remember, X comes out of the graph, out of the plane, and Y is horizontal. So this is a horizontal circle. If you cut through that, if you took a sphere and sawed right through it horizontally, you would get a circle, and that's called an XY trace. All you do to find an XY trace is you put 0 in for Z, because you want to get rid of the Z. You're going to end up with the equation of a circle, so you only want 2 coordinates. If it's a YZ trace, well, that's vertical. That'd be right on the plane of the paper, because Y is horizontal and Z is vertical. There, you want to get rid of the X, so you put 0 in for X. And then an XZ trace, that's coming out of the paper and vertical. So there you want to get rid of Y, so we put 0 for Y. So here, if I want to find an XY trace for this, we're going to put 0 in for Z. So we take this equation. I have X minus 3 squared plus y minus 2 squared, because those didn't change. Now for z, I'm going to put in 0. So 0 plus 4 is 4 squared equals 25. Now we want to move that to the other side, so let's leave the x squared and the y squared. Don't have to multiply them out or anything. That's 16. If we subtract it the other side, we get 9. So notice that's the equation of a circle. That's an xy trace. We also want an xz trace. Well, for an xz trace, we want to get rid of y, so we set y equal to 0. So again, nothing happens to the x minus 3 squared. Now we're going to put 0 in for y. 0 minus 2 is a negative 2 squared. Now this time the z is going to stay. So it looks like that. Now to simplify, we're going to leave the x alone. Negative 2 squared is 4. We're going to move that to the other side. 25 minus 4 is 21. And leave the z alone. Again, that's the equation of a circle, and the two coordinates are x and z. And that's it for 3 dimensions. So again, almost everything we did there except the graphing and the trace was exactly like we did with 2 dimensions.